Hello aspirants and welcome to Prakashbindu Academy. यहाँ हम फिजिक्स को मास्टर करते हैं, बिल्कुल फंडामेंटल से लेकर एडवांस्ड लेवल तक. आज we're diving deep into a really interesting topic, surface tension. ये एक बहुत crucial topic है आपके NEET और JEE preparation के लिए, and you know, it explains so many things, from why raindrops are spherical to how insects can literally walk on water. So let's kick things off with a question I'm sure you've all thought about at some point. देखो इसे. ये सवाल है ना, it perfectly introduces the concept we're going to master today. How on earth is it possible for a tiny insect to just stand on water, almost like it's a solid surface, but we can't? Well, the entire secret, the answer, lies in one single concept, surface tension. Okay, so to really get the answer to that question, we need to zoom in. I mean way in, right into the molecular world of a liquid. Let's try and understand what's actually happening at the surface. चलिए देखते हैं कि ये जो word है, tension, इसका यहाँ असली मतलब क्या है? Alright, so imagine you're a tiny molecule. अगर आप liquid के बिल्कुल अंदर हो, deep inside, तो आपके चारों तरफ आपके neighbors, यानी दूसरे molecules हैं. They're all pulling you equally in every direction. So you're pretty happy, balanced, content. But what if you're a molecule right at the surface? Suddenly, ऊपर कोई नहीं है. There are no neighbors above you to pull you upwards. इससे क्या होता है? एक imbalance create होता है, a net inward pull. और इसी inward pull की वजह से the liquid constantly tries to shrink to minimize its surface area. And that net inward pull? That, fundamentally, is surface tension. That's the whole idea. Formally, we define it as the property of a liquid that allows it to resist an external force. Or you could say it's the tendency of its surface to shrink into the minimum possible area. Think of it like a stretched elastic membrane, right? It's always trying to pull itself together. The formula is simple. T equals F over L. And the SI unit, of course, is newtons per meter. Oh, and one more thing. It's also defined as surface energy per unit area. Don't forget that. So, is the concept clear? I hope so. Great. Now that we have the why sorted out, let's get into the how. We're going to look at the applications and, more importantly, the key formulas you absolutely must know for your exams. These are going to be your tools for solving numericals in both NEET and JEE. Okay, let's take our first case, a simple liquid drop, just a single drop. Now, because that surface is trying to contract, it's squeezing the inside, right? So it makes sense that the pressure inside the drop has to be greater than the pressure outside. But by how much? Well, that excess pressure, which we call delta P, is given by this super fundamental formula, 2T divided by R. Simple. T is your surface tension, R is the radius of the drop. All right, now for something a little different, a soap bubble. Now, think about it. A soap bubble isn't like a solid drop, is it? It's hollow. That means it has two surfaces in contact with the air, an inner surface and an outer surface. And since both of those surfaces are trying to contract inwards, what do you think happens to the excess pressure? It doubles. Exactly. So the formula logically becomes delta P equals 4T divided by R. And this right here, this is a classic trap in JEE and NEET questions. They love to test you on this. You have to read the question so carefully to see if they're talking about a liquid drop or a soap bubble. The key difference, the only difference in the formula, is that factor of 2. For a drop, it's 2T by R. For a bubble, it's 4T by R. It sounds simple, but trust me, it's a critical detail that can cost you marks. Okay, now let's see what happens when you put a liquid inside a container. यहाँ ना एक battle of forces चलती है. On one side, you have cohesive forces. ये होते हैं liquid के अपने molecules के बीच में. Think co like coworker, same team. On the other side, you have adhesive forces. ये हैं liquid or container के molecules के बीच में. Think adhesive like tape, sticking to something else. इनको जो balance है ना, that's what decides the contact angle theta. As you can see with water, the angle is acute. इसका मतलब क्या? Adhesion is winning. The water wets the surface. But for mercury, the angle is obtuse, which means cohesion is much stronger. The mercury pulls itself together and doesn't want to touch the side. And this battle of forces directly leads to something called capillary action or capillarity. अगर आप एक बहुत ही पतली ट्यूब, जिसे हम capillary कहते हैं, liquid में डालते हो, तो you'll see the liquid either rise up or fall down inside it. But how much? कितना ऊपर या नीचे? Well, that's governed by Jurin's law. The formula is right there. H equals 2T cos theta, all divided by R rho G. Now, every single variable here is important, but pay special attention to that cos theta term. It's crucial. All right, so we've gone through the concepts, we've looked at the formulas. Now it's time for the most critical part, the part that directly impacts your rank. How to turn this knowledge into marks, and just as importantly, how to avoid those common traps. So listen up, because this section is your key to truly mastering surface tension for your exams. So look at this table. It perfectly summarizes the 3 most common silly mistakes that lead to negative marking. Number 1, forgetting that factor of 2 for bubbles. We just talked about that. Number 2, completely neglecting the contact angle, just assuming it's 0. And number 3, a classic, making simple unit conversion errors. My strong advice? Take a screenshot of this slide. Keep it for your final revision. It will save you. And now, as promised, here's a rank booster trick for you. This is a master formula for a very specific situation called droplet coalescence. This is when lots of small drops, let's say n of them, combine to form one single big drop. Now, you could derive the energy release from scratch, but using this direct formula will save you precious minutes in the exam, so note it down carefully. The work done, or energy released, is 4 pi r squared t multiplied by the bracket n to the power 1/3 minus 1. Remember, r here is the radius of the final big drop. Okay, let's quickly wrap this up. It's time to summarize the absolute most important points, the things that you need to have crystal clear in your mind right before the exam. Think of this as your final revision checklist for surface tension. So to quickly recap our key takeaways. First, the fundamental cause. It's all about that unbalanced inward pull on surface molecules. Second, the factor of 2. This is non-negotiable for soap bubbles and films. Third, the 2 excess pressure formulas. Delta P is 2T over R for a drop and 4T over R for a bubble. Got it? Fourth, for capillarity, remember that height H is inversely proportional to the radius R. And finally, don't forget the external factors. Surface tension goes down as temperature goes up, and adding impurities like soap also decreases it. You know, aspirants, mastering topics just like this one, getting into the details of surface tension, that is the little extra effort that will turn an ordinary rank into an extraordinary one. Apni mehnat par vishwas rakhiye. Keep pushing forward, stay focused, and you will, without a doubt, achieve your goal. All the very best.